For us to test the input bypass relay, we need to pass a 5-volt signal. The 5-volt signal simulates the axle signal that we get on the cruise, that we get from the car, and this 5-volt signal is generated using a DC signal from a signal generator. As you can see that it is passed through the axle underscore signal cable, and this is connected to the contact of the upper section of the relay. As you can see, if I measure the voltage at that point, it gives you a 5-volt signal, which shows that the signal generator is passing a 5-volt signal into the contact of the relay. In this section of the test, we are passing the same 5-volt signal from the signal generator through the region underscore signal of the relay. Now, the region underscore signal is actually connected to the second contact, the bottom contact of the relay, and it should read 5.05 volts when measured across it. And as you can see from the multimeter, it gives a 5 volt, which shows that the signal generator is passing a 5 volt DC signal into the contact of the region underscore signal section of the relay. The normally open contact is the section which feeds into the potential divider. The normally closed is the one which feeds it into the motor controller axle, which is connected from the second relay. And therefore, if we connect the voltmeter across the normally open contact, it should give 5.05 volts. But at this stage, the relay is not energized, it's not switched on, and therefore it's passing the axial underscore signal, the 5-volt signal, through the normally closed contact of the relay. And as you can see from the voltmeter, it's passing the 5.05 voltage. The relay is not energized, it is not switched on, and therefore it is passing the 5-volt signal from the region underscore signal to the normally closed contact, and that's the 5.05 volts that's been recorded. On the normally open contact should be 0 volts, and the normally open contact is actually feeding the signal into the resistor divider block, and therefore if we measure the voltage across the normally closed region of the contact, it would give you a 0 volt. As you can see from the multimeter, relay is not switched on, and therefore we must expect a 0 volt across the normally open area, normally open contact of the relay, and it is 0 volts. The gate source voltage, the gate sink voltage should be 5 volts. And if I measure if I place a voltmeter across the VGS, we can see that the voltage is 5 volt. Here in this video, there's a click, and it shows that it is switching between the contacts from the normally open to the normally closed. Now we are testing the axle underscore signal section of the relay, and the voltmeter has been connected to the normally closed contact, the normally open contact, and when I press the cruise enable button, it energizes the coil of the relay and it turns the relay on, and it should switch from 0 to 5.04 volts. And voltage across the normally closed and normally open contacts of the region underscore signal, and when I press the cruise enable switch, the voltage across the normally open contact should now be closed and should give me a voltage reading of 5 volts. As you can see from the voltmeter, it gives a 5.04 volts. We have connected an ammeter, and the ammeter measures the current that's flowing through the drain and into the sink. And when we press the cruise enable switch right here, it should give there should be a draw. There should be a current in the range 101 to 160 milliamps flowing in through the drain. Therefore, as you can see, when I press the switch, the ammeter shows that there's a current drain of 101.8 milliamp.